Alright, so where corresponding angles and alternate interior angles get used is when, with the following rule. So this is very important. When a transversal intersects two parallel lines, the corresponding angles are congruent. So remember, congruent means that they are the same. So when we look at this example, so example 2, the following segments form parking spaces, and they are parallel. So we're looking at like a parking lot. One more. Alright. And we want to know what is the measure of angle 1. And so we know that this angle is 100 degrees, and this angle is 80 degrees, and here is the angle 1. So in order to solve this, remember, this is my transversal. I'm going to look at my parallel lines. So angle 1 is on this parallel line, and I also have an angle measure on this parallel line and an angle measure on that parallel line. And so those are what I'm going to concentrate on. Now, angle 1 is on top of my transversal, and so when I'm looking, the 100's on bottom. It is not inside my angles. Angle 1 is not inside my parallel lines, so I can't use alternate interior. So the 100 doesn't help us here. So then I look at the 80. Angle 1 is on top, 80 degrees is on top. The angle 1 is to the right of its parallel line, 80 is to the right of its parallel line. So what I know is that angle 1 and the 80 degrees are corresponding angles. And because they are corresponding angles, while we have parallel lines, that means that the measure of angle 1 is 80 degrees. So when it comes to your homework, you are going to write 80 degrees and then corresponding angles. We're going to go ahead and get in the habit now, for when we hit high school, of justifying why something is what it is. So, angle 1 is 80 degrees by corresponding angles, or because of corresponding angles. So, what is in this red box is what I am expecting to see if you are wanting full credit on your homework, or on the work part of your homework. So that's our second example. Again, angle 1 and angle 3, or not 3, angle 1 and the 80 degrees are both on the same side of the transversal and in that corresponding position. So both of them are to the right of their parallel line. So that was corresponding angles. So then we have what we call a theorem about alternate interior angles. So when a transversal intersects two parallel lines, then the alternate interior angles are congruent. So this is very similar, it's just with our alternate interior. So on example 3, we have Andy. Andy is working at a dude ranch, and she's repairing fences the rails of the fence are parallel. If it does not say that so-and-so lines are parallel, you cannot assume they are parallel. You need something to say that they are. So here, let me draw an image of our fence. So here are our rails. Here are more rails. And let's see how well, awesome. I have that this is 40 degrees and this is our angle 1. And so angle 1 is what we were trying to find. What is the measure of angle 1? So now when I look at this one, it helps if I notice what is my parallel lines. So I am highlighting my parallel lines. It would also help to increase our transversal. So here's our transversal. So parallel lines cut by this transversal. I'm looking at these two angles. I ask myself, are they on the same side of the transversal? The answer is no. So then that means they can't be corresponding. And then are they inside my parallel lines? And the answer to that is yes. Angle 1 and angle 40 are on opposite sides of the transversal, but they are both inside my parallel lines. So that makes them alternate interior angles, which means that the measure of angle 1 is equal to my 40 degrees. And that, again, is by alternate interior angles. That is what you write on your paper. Because yes, it's not hard to notice that that is 40 degrees. But the work that we show is that we put our answer and why that is our answer. Was it corresponding angles or alternate interior angles? So what we have next is, can we prove angle or lines are parallel? So before, if lines were parallel, we could prove angles were congruent. Now we're going to answer the question, can you conclude that line A is parallel to line B? And then we need to justify. So this is what section 2 is about, but it uses the same concept. In order to prove lines are parallel, our corresponding or our alternate interior angles have to be congruent. They have to be the same. And so here are two lines, and no, you cannot just look at it and say, you know what, Mrs. Cartwright, you drew some pretty almost parallel lines, so that means that they are parallel. We actually have to look at angle measures. So here's our first one that we're going to answer. I'm looking at two lines. Here's line A, line B. I'm looking at the two angles given. All right, I notice that they're the same side of the transversal and that they are both sitting at the bottom of their line. And then I look at their measures. So this first one is at 59 degrees and the second one's at 59 degrees. So this one, can we conclude that line A is parallel to line B? And the answer is yes, we can, and that is because the corresponding angles are congruent. That's as simple as it is. Again, that is your work. Yes, why? Corresponding angles, alternate interior angles. That's how we're going to be proving that our lines are parallel. Here's another one. So I would call this example 4. So then we could call this example 5. Two lines, we're going to call them A and B again. And our transversal, here we are at 121. and 122. And so then we ask ourselves, are they on the same side of the transversal? No, they're on opposite sides and they are inside, so that means these are alternate interior angles. So then the next question, once I recognize what type of angles they are, is I ask myself, would that make these lines parallel? And the answer is going to be no. And that's because the alternate interior angles are not congruent. And since they're not congruent, then the lines are not parallel. So that's how we justify whether lines are parallel or not parallel. Are the corresponding angles congruent, or are the alternate interior angles congruent? And if they're not, then the lines are not parallel. One last example, example 6. So here we have two sets of lines with technically two transversals. So here's line A, B, C, and D, and then we're going to label this 1, 2, 3, 4, 5, 6, 7, 8. And so what we want to know, I'm going to give us statements, and we're going to put them, either they prove A is parallel to B, or they prove that C is parallel to D. So the first statement I'm going to give us is that angle 2 is congruent to angle 10. So here's angle 2, here's angle 10. I notice that they are on the same side as line C, and that they are both sitting on top of their lines. And so what that means is I have a pair of corresponding angles. Now these corresponding angles are on, C would be my transversal. So if C is my transversal, that means that angle 2 congruent to angle 10 proves that line A is parallel to line B, because A and B would be our parallel lines. Next one, angle 3 congruent to angle 6. So again, I'm going to circle these. Angle 3, angle 6. So when I'm looking at these, I notice that they are not on the same side of a transversal. They're on opposite sides of transversal, and that transversal is A. So then I look closer and I notice that they are both on the inside of C and D. And so because they are opposite and inside, that means they're alternate interior angles. Since their transversal is A, and they are between lines C and D, that means that it proves angle 3 congruent to angle 6 proves that line C is parallel to line D. Let's do another one. Angle 4 congruent to angle 12. So here is angle 4. We'll put a square here, and here is angle 12. So looking at this, we are on the same side of our line D, and we're sitting on top of line A and on top of line B. And so that means that we've got corresponding angles here. And so since our corresponding angles are between A and B, and basically because our transversal is D, our two lines that we're cutting are A and B, that means that angle 4 is congruent to angle 12. Let's do one more. Angle 7 congruent to angle 12. So here we're looking at angle 7. I'm going to put a star on 7 and a star on 12. So when I'm looking at these two, they are not on the same side of the transversal. So they're on opposite sides, and they are between my lines A and B. So D is still my transversal, and they were alternate interior angles, so they're going to fall in they show that angle or line